Let's talk about functions. Now, what you see here is you see the eponymous Hello World program written in Java. And you have a main method. And just as a review, you should know what the main method does. Remember, the main method in Java is the method that is automatically invoked when you start the program. Now, different languages will have different methods that are invoked, immediately after you start the program. So I'm not going to really harp on the main method, at least that much, with this example. But I do want to talk about methods in programming in general, and specifically here in Java, we're just going to illustrate, or I'm going to illustrate, how functions / methods are used. Now, what you see here is you see the main method in Java. Now, let me kind of explain a little bit about the terminology, because I use the term function and I use the term method. And you're thinking about it, you're like, well, are they different? What are they? Now, when you go further into your studies of programming languages, you're going to study something called OO design, or object-oriented design, or OO programming. Now, OO programming is a little bit beyond the scope of what we're doing here. But in OO programming, you're going to learn a lot of object-oriented architecture issues, such as how methods and functions may differ a little bit from each other. Because they are different, but for our purposes today, I'm going to interchangeably use those two terms. Method and function used here really mean the same thing, but that's going to change again a little bit as you expand your studies into programming. Now, what you see here is you see the main method. It's the entry point into a Java program. Now, you probably have already done some programming where you've put something in the main method. Here we're just saying hello world, and this is going to echo out to the command line. When we run this, it's going to say hello world. Easy peasy. And also, you may have done things in your main method, such as put in other programming. Maybe you've already done things, such as putting in other code, if statements, while statements, anything to do things. So, as you probably could imagine, your main method gets really busy, right? So what happens is, the more you put in it, the more it does, and the bigger and bigger and bigger and bigger it gets. Okay, now, in programming in general, big methods, sounds like a band or a country band, doesn't it? Big methods. Please welcome to the main stage at the DuPage County Fairgrounds. Big methods. All right, maybe I'm thinking of Big and Rich, right? Anyway, so big methods are a bad thing in programs. When you write a program, you want your methods to be fairly small. There's not a real test to it. We'll go over a little bit, how big they can be in the end of this demonstration. But for the most part, methods are supposed to be kind of as small as possible. And you're looking at one right here. You're looking at the main method. Remember, the main method is built in. Probably should stop saying that, which means that you don't have to define it. It's defined for you. The main method is a magical method that fires off when you start a Java program. Now, you are encouraged, actually really required, to write your own. You don't write really much stuff, if anything, in the main method, except just start, doing something. What does that mean? All right, well, let's start by writing our own methods. Remember, methods, maybe not remember. This is the first time you're seeing it, presumably. Methods are just different parts of code or different functions in code which you define what they do. What does a method or a function do? Again, I'm using those terms interchangeably for now. Anything you want, right? It really depends on what you want them to do. Think of a method or a function being an empty file cabinet. What you put in it and what it does is really up to you. But let's talk a little bit about the construction of a method, specifically what you see here. All right, you see public static void main string args. Now here's the rub with this. This is something that you need to know, but you don't need to know in the next 10 seconds. Maybe not even in the next 10 days, but somewhere in the next 10 days to 10 weeks, you kind of need to know how methods are constructed. Okay, it's not something you're going to memorize today, but you're going to start. So I'm going to start with this. And again, if you're writing notes, write them in pencil because this is something that you learn as you go. Okay, public just means that this method is a public method. What does that mean in English? Again, this is the Cliff Notes. A lot of this is going to be fleshed out a little bit more. This is just the first step. Public just means that this method is known by any other programs, right? Right now we have one program called Hello World. Public just means that this method is known from any other program other than Hello World. Maybe I have a program called Goodbye World. Okay, Goodbye World would know about the main method in the Hello World. So it's basically the access to this method. The vocabulary term for this is called an accessor. I can't spell that. ACCESSOR, accessor. I don't know. But the English term is accessor. This is the accessor or the access for the main method. It's public, meaning that other programs know about it or can find it. It's there. There's also some other ones as well, of which we're not going to really talk about here in depth. But since I let the cat out of the bag a little bit, we also have private. Private means that this method is only known to this program itself. And we also there's some ones that are in between. Like we have one called friendly, which means it's only known to like subclasses of this class. And we also have protected. Protected means that it's kind of like in the middle. It's known to other methods within Hello World, but not anything outside of it. So that's a whole bunch. So don't worry about if your head's exploding on that. These things will become more obvious as you go. Just know for now that public is an accessor. It just means that this is a public method. Now static. You know what? I'm going to skip this for now. Skip it. All right. I promise at some later date, we're going to talk about static. But what this means, here I go again. That just means that this method is only one per class, not per instance. You have no idea what that means. You don't need to for today. You don't need to know this. Okay, void just means what this method returns. This method can return a value. For example, we're going to write a method that's going to add two numbers and then return a value. So void just means that this method returns nothing. That means that we pass things into it and we don't get anything out of it. Then you have the name of the method, which is main, and then you have what we're passing into it. These are called arguments or parameters. All of this here is called the method signature. The signature just means what is the name, what is its access, what does it return, and what are we passing into it. Baby steps. Baby steps. Okay, so how about we do this? Let's write a method that's going to add two numbers. So how about we do this? We're just going to get rid of this Hello World for now. And we're going to declare two numbers. I'm going to put in int, and I'm going to put, for the name, we'll put in num1 and int num2. And then another integer, result. There we go. And quite simply, we will say result. Whoops. Equals num1 plus, hold on, I'm getting a fat finger syndrome here. Result equals num1 plus num2. And we'll write that out so we can see it, right? Why not? Why are we doing it? Because we can. result equals result. Okay, so I'll give you guys a sanity break. I'm going to drink a water. You can pause the video for a moment if you like. Okay, so this is fairly straightforward. Now you should know something about variables by now. So what I'm doing here is I'm using whole numbers, right? I'm not using real numbers, so there's no decimals. Remember, maybe not remember, but recall, if you do already know, that you can't really mix real numbers and integers and real numbers and integral numbers. Integral means whole numbers in programming. So here I'm just kind of going down the happy path, just kind of avoiding that. So we're just going to add two integers and get the result. So we haven't wrote a method yet, or a function yet, so let me do some cleanup. So we look just so. And let me execute my program. Doesn't like this. If you ever get that in tutorials point, if you ever get that object required, which means I got a syntax error. So let me quickly look to see what my problem is. And I look all right. Hold on, I'm looking at my syntax. Remember, we have to end with a semicolon, and that looks like it's good. This looks good. This looks good. We have a string called result. We're concatenating. Plus means concatenation for strings. It means addition for numbers. And this looks okay. So let me give this another shot. Okay, so when I run the program, I get an error message here that the variable has not been initialized. And to solve that problem, I'm just going to initialize num1 to 0, num2 to 0, and I don't need to initialize result because result will be initialized right here. So anyway, I'm not doing a method yet. So let me run the program, make sure it works. And it does. Result equals 0, right? So let's initialize num1 to 39 and num2 to 12. I run the program and I get result equals 51. Okay, now that's all good and fine. We learned a couple things along the way. One is we needed to initialize our variable or assign them. And here we're declaring our variable and we're assigning it on the same line. Perfectly fine. Now let's talk about methods now. Now here we got everything in our main method. In reality, we probably would, as a design consideration. Now remember, I just said design consideration because there's no manual that says this is when you use a method. Methods aren't necessarily syntax, meaning there's nothing in your compiler at runtime that'll say, listen, Bob, you should be using a method here. It's a design consideration. This is the analogy I give for methods. Remember high school? Remember how, you always would have, if you're as old as me, you didn't have backpacks. You had what was called a trapper keeper, right? And your trapper keeper had different color folders in it. And you had one for math, one for science, one for language arts. If you were organized, that's what you did, right? If you were me, you didn't have folders at all. You just had this one big thing and you just shoved it all in there, right? Now, those are two different ways of organizing things. Now, there's not one right way or one wrong way, although you probably could make the argument, certainly with pretty good effect, that the student that has everything organized neatly in folders probably has a better organizational method than me, the one that doesn't. Okay, but I could always argue that, well, not really, because I didn't have to worry about what folder to put my stuff in. It's all in one place. But anyway, methods and using functions, I'm just going to use the term function for now, so I'm not confusing you or me. Functions are like that. So functions are really the way of you organizing what your program does. That's all it is. No, there's no function police that's going to come out at design time and say this is what you should be doing. And these are the functions that you should be using. Now, However, there are points when you start writing this stuff professionally. Right now, you probably don't know this because you're new, but in the real world, if you're writing this for, for a large organization, you have what are called code reviews or peer reviews, where you all sit down in an office, in a conference room, you order pizza and Jolt Cola on Friday, and you go over each other's code. And you critique it. You should be doing this, you should be doing that. This is something that usually comes up with that code review. Someone will look at your functions and say, Bob, you're doing a lot of stuff in this function. Why don't you break it into smaller, more understandable, segments so someone like me could look at it and know what you're doing. And if you pass this program to someone else, they can look at it and know what you're doing. Right now, and again, I'm speaking to the class now, we don't think that way because the programs that we're writing are really small. So you're like, I know what I'm doing. Look at it. I could see clearly what I'm doing. But if this program was thousands of lines long, it happens, absolutely, and I had everything in one function, someone is going to call that out and say, that's not the way you should do it. Or as we say, you're doing it wrong, which is, slang for just because it works doesn't mean you're doing it the right way. So functions are part of that. How you write your functions and where you put them and what they do is up to you. But it has more to do with reusability, readability, self-documentation, all that. I mean, think about it. This is a good example, or maybe not. Think about your phone book. Again, if you're under the age of 30, you don't know what a phone book is. But if you're older than that, me, I'm 31, you remember phone books. Phone books used to arrive on your porch every day. I live in the city of Chicago. Our phone book was huge. As a kid, it was a huge, big thing. Phone books used to be a big deal, too. I mean, if you lost your phone book, you had to go upstairs or find your neighbor downstairs or across the gangway and borrow their phone book because you just didn't have yours. Now, phone books have millions of phone numbers in them. Imagine if that phone book wasn't divided into businesses and residences. And imagine if it wasn't done in alphabetical order, right? Look up Hendry. Let's look in the H's. And then it's in alphabetical order, H-E-N. Oh, there he is. They live at 3600 North Lakeshore Drive, Chicago, which is my address. So anyway, so functions are like that phone book that have like the different letters that have you look it up. And also functions are in the phone book will be organized by what we call alpha sequence, which means it's in, it's sorted by the last name. Functions are like that. So functions give you the ability to take a whole bunch of stuff, information or instructions, and put it in a readable and format where someone else can look at it and kind of figure out what's going on. So how about we do this? With that design pattern in mind, we're going to write a function that's going to add these two numbers. Now you're going to look at it and say, why are we doing a function when we could just do it right here? And that's certainly up for discussion. So let's build a method. Public. And again, just to further confuse things, say that 10 times fast. Remember, we're using the term method and function interchangeably, although technically they're slightly different things. So I'm using the 80-20 rule just to kind of skip by all the little details just to sell you the big idea. So we'll say public static void. So public method static void. We'll say this is add numbers. Now in add numbers, we put in its signature. Or what are we passing into it? We're passing in an argument. Again, we're passing into this function two numbers. So we have to declare the data type of the number and what do we want to call it. So we will say we're passing in an int and we're calling it, and I'll put A. A stands for argument. A is just a naming convention. I could really call this anything I want. We'll put in A1, comma, and another number, A2. Now methods have their own block. So here we got start for the main method, end for the main method. We have start for the add numbers method, end for the add numbers method. This is called the class block. So we got the start for this and the start and the end for that. All right, so let me kind of clean up these blank lines just because I'm anal retentive. All right, so let's add these two numbers up. So we're going to pass in A1 and A2, and we're going to declare another integer and call this my result is equal to A1 plus A2. And we're going to write that out. So let me do some quick coding here. Now we're going to call the method. So we're going to, rather than doing the arithmetic in the main method, we're going to call our new method called add numbers. And quite simply, you can just say add numbers num1 and num2. All right, I'll stop typing for a moment after this. Pause the video and ponder. Or as a Saturday night live skit goes, talk amongst yourself, talks amongst yourself. So pause and absorb. And after a couple of minutes, after you're done playing what is connected to what, restart the video. I'll give you about 30 seconds of silence. Okay, welcome back. Just had a sip of coffee there. So I haven't run this yet, so I don't know if I have any compile errors there. So I don't know if it's like right yet, but we'll see. So anyway, the main method, again, this is where we start. Then we don't need, you see, we don't need result anymore here. We have two numbers, two integers of the value 39 and 12. We're passing them. See, 39 goes here. 12 will go here. We're passing it to a function. I know I keep going back and forth between function and method, even though I promised I wasn't going to. So never trust a computer science or a math professor. Okay, so then we're passing those numbers into this method. This method is adding them up, putting the value in a variable called myResult and passing that, and then printing that out. So let me execute the program. And like I said, I don't know if I have any compile errors in here or not. So let's give it a go, give it a try, and see what we get. Oh, there we go. You know what? Just it didn't change, right? Because the numbers. So let me just change this just to make sure that we're really running it, just for the paranoid here. And result equals 58. So we're good. All right. This is all I really wanted to show you for today. Next up, we're going to continue. We're going to continue with methods and functions and arguments and all this other stuff. But this is really the basics of declaring a method and calling the method. That was really our objectives, was, the theory or the reason behind methods and what they're used for, why you need them. Then how do you declare one? What are the things that you need to know to declare one, and then how do you call one. So those are the three objectives we had, and we've satisfied those. So this is as far as I want to go. But let me kind of sum this up with some closing observations and remarks in it. Now, one is we got different variables here. This might be off the topic slightly of methods. We started this example with the main method. The main method has two integers in it. We also declared a method, add numbers. This method did not exist until we created it. We have another integer called myResult. These integers are not accessible in this method. So the integers that we declare in main are not accessible in the method that we call add numbers. And also, we have myResult that is declared in add numbers. That's not accessible in the main method. Now, again, we're a little bit off topic, but that's a concept called scope, or the variable scope. We could say that these integers are local to the main method, and this integer is local to this method. Methods keep their own variables to themselves for the most part. Remember how we talked about methods, and methods have accessors like public, static, like public and private. You generally have the same rules with variables. For now, let's skip that. Again, I don't want to put too much in your head right now, because I look at this, and any second or third year computer science student would look at this and tell me that I'm just leaving out a whole bunch of stuff, which I am. I'm just trying to get the first steps down so we could get something working, and so you could get a body of work that you could do on your own and know what you're doing, and know that you say, oh, you know what, this is really a 100 level programming class. We're going to cover some of the rest of the stuff later, or maybe, in a different class. So this is not an exhaustive video at all on methods, but it's a beginner primer that gets you all started. All right, folks, that's all I had for you today. So thank you for watching. Thank you for taking time out of your busy day to go over this with me. And I bid you all a very well rest of the day. Thank you.